Welcome everybody, Dr. Pete here. Today's episode on the first day of 2023. Mitochondrial dysfunction is a driver of gout, and we start right now. So the issue is, and this has been sitting out there now for 4 years, right? I talk about how when you have the situation with a hyperglycemic meal, you have added sugars coming in with the fructose, and you have alcohol all showing up at the liver at the same time. This is that concept of having a large number of calories, all of these different macronutrients arriving at the liver at the same time, and hyperactivating glycolysis, which causes the pushing of the excess glucose over into endogenous fructose, where it then enters into the fructose biochemistry there. The added sugar with, I call it exogenous fructose, coming in, which comes in directly. Remember, fructose uric acid pathway, unlike glycolysis, the fructose uric acid pathway is unregulated. So I've talked about this analogy before. If you think about the liver, and if somebody's having a low carb meal, for example, then there is this incoming glucose. It's not hyperglycemic. And the function of glucose is to produce ATP to fill up the glycogen store so that, we have energy going down the road. And if there is a slight excess, the additional glucose there is pushed into the production of fat. Now, when we overload the system, what's going to happen is the glucose piles up at the front end of glycolysis, and the glycolysis pathway is overloaded. The excess glucose gets pushed via polyol pathway. It's a two-step process into endogenous fructose. We have the incoming added sugar that has the fructose in it. So we have the combination of exogenous fructose. This is the fructose coming in from the meal itself, and then the fructose is converted from the glucose. Up to 30% of that glucose is pushed over into the endogenous fructose. Then that fructose together and collectively in an unregulated fashion basically is going to collapse into the sudden acute rise in uric acid on an intracellular basis, with a decimation of ATP in the cell and also the phosphate. And this translates into an elevation of systemic inflammation, the disruption of nitric oxide pathway, and a reprogramming of the liver into de novo lipogenesis. So basically what that means in English is that the liver is going to stop burning, right? We're going to stop burning this incoming material to produce ATP and to do other things that the burning pathway does. And instead now we're storing everything that's coming in. And we have basically this growth pattern, which we know when that is activated on a chronic level is where we end up with the dysfunction. And ultimately that starts with the captain of the dysfunction, which is the mitochondria. And that's really an introduction to what we're going to talk about today, is what's going on with the mitochondria. So remember, when we go back to the gout, the issue of the gout, this is my hypothesis. And the last time I was here, I talked about early data that actually supports this. We're going to go back and review that quickly in a minute. But the idea is that we have the biologically important cell inside the joint, the chondrocyte. And the function of the chondrocyte is to maintain the extracellular matrix there, the lubrication, all the things that you need for a healthy joint. But with years and years of the deadly triad and potentially the sleep apnea, which can be associated with those conditions happening on a chronic level, we know that the chondrocyte can be pushed into a state of low-grade inflammation. And in low-grade inflammation, basically that cell is primed for a particular event. And a couple of things that seem to be going on when the chondrocyte is in that state is the intracellular production of uric acid. And that uric acid will be pushed out into the extracellular environment around the chondrocyte, and this is an important thing to think about. And then we're also going to have the production of IL-1 beta. And I believe that as part of this situation, if you will, is that the IL-1 beta is responsible for recruiting the innate immune system. This is going to be the macrophage. And the macrophage is going to be interacting at once, not only with the IL-1 beta, but also with the uric acid, which may or may not be crystallized. I'm going to come back to this earlier hypothesis in a second that was published in 1975, which is really important to us. There was a lot of high quality science that was done in this area that for whatever reason has been forgotten, or at least not paid attention to, but I am paying attention to it. So let's take a look at that hypothesis, because it's really important to this, right? Because once the macrophage gets involved with this, and once we have crystalline uric acid there, then the macrophage is going to respond to that by inducing this inflammatory event, which involves other immune cells, the neutrophils, and so on. But this is how we get to the gout flare. So this is the hypothesis that was developed in 1975 by Wilcox and Califf. And the idea here is that you have a chondrocyte, which is producing monosodium urate. And in the process of this low-grade inflammation, one of the things that we know about the chondrocyte, we also know this about the macrophage, is that both of these cells are specialized in glycolysis. And under conditions of hyperglycemia, both the chondrocyte and the macrophage are going to push glycolysis towards the overproduction of lactate. And once lactate is leaked into the extracellular space that is surrounding the chondrocyte, this causes an increase in acidity, which these guys were able to show via high quality research causes a disruption of the proteoglycans there, degradation, along with degrading enzymes that are there, right? And I've talked about some of those in my previous discussions, like MMP3, for example. And in the process of that, we have the release of calcium. Mechanical disruption. So say you stub your toe really, really bad, or historically that happened at some point, like it did with me, preceding my gout flare by a number of years. This mechanical disruption can also lead to this pH decline that we're talking about here, and also the rise in intracellular ionic calcium. The main point, the reason we're talking about this acidity and the calcium is because the hard part of crystallizing uric acid is the actual nucleation event. This is the rate limiting step. And it explains why, when you step back from this and you think about the hyperuricemia data, right? Hyperuricemic data. That's the 43 million people that are walking around with high uric acid that don't necessarily get gout and don't necessarily form monosodium urate crystals in their joints, probably has more to do with what we're talking about right now than any other single issue. That you must have these local conditions, right? The release of the calcium and the acidic conditions locally in order for the monosodium urate to nucleate. And then once you have the nucleation, you can get growth of the crystals. Once we have the crystals, then they can systematically interact with the macrophage that I show over there on the right side. And then we go down the slippery slope that I talked about on the last slide and end up in the gout flare. And this is just a depiction of that event. I pulled this. Let me just give you the proper reference. This was from a 2002 paper, Mobashiri et al., that focused on the metabolism of chondrocytes. And it is an old reference, but what I like about it is they have some really good diagrams where they put this together. And so you can see the collagen strands in there, and you can also see proteoglycan. So this is just putting together now in a simpler format what we just talked about. You have a chondrocyte that's suffering from low-grade inflammation, acidification of the extracellular environment around that, the release of IL-1 beta. You have the attraction of the innate immune system. And I have another reference for that. That comes from Early et al. And this is a paper that was published in 2021, which is proposing that the mitochondria is at the center of this stuff, because we have what I believe is a metabolic issue going on. And at the center of metabolic dysfunction is the mitochondria, how the mitochondria is responding inside the cell to these conditions that are happening. I'm talking about the hyperglycemia, the role of fructose, the role of the hypoxia, and so on, because those have a profound effect on how these cells are metabolizing. And I say these cells because we can't look at the chondrocyte in isolation. We have to consider what's going on with the cells of the innate immune system, because they are being subjected to the same metabolic conditions as the chondrocyte. And remember what I've said in the past, the danger of isolating these things is exactly the reason why we are where we're at now in 2023 and still suffering from gout. Basically, we need to be able to step back, big picture, and try to understand what's going on with these cells in the joint in order to come up with strategies to get the gout remission.